Hi, everyone. Welcome to Engineering Analysis and Data Science for week, I believe, 11. We're chugging right along. So for this week, we're going to be uploading your data set into R, or your portion of your team's data set into R. So there are 4 general steps to doing this. The first is to watch this video, which you're already doing. Then to download your data set from your website. As we discussed in some studio engagements, and I've mentioned several times, it's the most helpful if you're able to download your data set as a CSV file, text file, Excel file, or delimited file. You can also then download your data, open it, and look at your data. Just check it to see what it looks like, if everything looks okay. And we might do a little bit of cleanup, which I'll go over. And then we're going to upload your data set or subset of your data set into R. And I'll be going over explicitly how to do each of these steps throughout this video. There are also some example code and commands here, along with 7 different references for tutorial videos, R for Dummies, data boot camps, a lot of different information and tutorials in case you get stuck or if you want to learn more for you to use this week. There's also a Swirl course in getting and cleaning data that might help you if you feel like you need a little more practice, and then a few hints for this week. I also want to mention, along with these 7 helpful links in the Swirl course, R is free and open source, so you can find out a lot of stuff for free right online. If you type in something like read.csv in R, which is a command that we're going to be using a lot this week, you can see all of these different links that come up that are helpful. There are videos, there are how to read this, in R for Dummies, how to use this to import data in R. It gives you some example code and things to work with right off of, a really quick Google search. There's also, you can Google search uploading data in R, and you can see there are a lot of different links and, once again, videos and helpful information about how to upload data in R, how to use the read CSV file. And a lot of times what I still do, even though I've been working in R for years, if I get an error in R, I copy and paste that error. I say error in R, and then I copy and paste whatever error is being given to me in R. And you can see there are a lot of discussion boards, community forums, open source areas, Reddit links that help explain to you what issue you're having and help you kind of correct it. You can also use the discussion board for this week along with emailing me. So there is a ton of information available at your fingertips in using R, since it is free and it is open source. So let's keep going. All right, I'm going to switch to the R Studio here and go over a few of the common questions and patterns that we noticed during last week. So the first one is, why are we using R? And the answer is probably threefold. The first is, R is a language that's been specifically designed for statistical analysis and data reconfiguration. So R is the most powerful statistical coding language, and it's commonly being used in big data, machine learning, and data science for this exact reason. So if you're learning data science, it makes sense for you to be learning a little bit of R. Second, R is free and open source. You don't have to pay for it. MATLAB, several other coding languages, the licenses are sometimes hundreds, if not thousands of dollars, especially if you're not a student. But R is completely free, which also means you can Google your problems a lot easier. There's whole GitHub forums, Reddit forums, all of these information about R, along with free packages, free software, free tutorials. So it's really easily accessible, but it's also the most powerful for data science and statistical analysis. In addition, most engineering programs, particularly accredited programs, will have you learn multiple languages. When I went to UF for my undergrad, I had to learn MATLAB, R, GIS, Python, SAS, SolidWorks, Simulink, and AutoCAD. It helps you develop your skills not just in one program, but in overall learning different languages and software, which is valuable as an employee and potentially going to graduate school. R is similar to MATLAB, but it's also similar to many other coding languages, such as Python, SAS, C++, Fortran, a lot of different languages. And so if you know a little bit of coding, it helps that you can probably code in a lot of different languages. And while R is similar to MATLAB, there are several big differences, mostly including the fact that R is much better at statistics. R is free and open source. So that's why you're learning R. I personally like R the best, and I hope that some of you will learn to like R the best as well. That's my goal for your educational experience. Some other notes: don't be discouraged if you are not good at R yet. You've been working on R for only 1 week. You've done one swirl lesson. If you're not very good at plotting or naming files or being really good at R, like, that's okay. That's not my expectation for you right now. I want you to know how to do basic commands, basic variable naming, and then start to work on doing some data uploading this week, and then some data interpretation later. And we will be providing some videos and links that will help you along the way. So don't get discouraged if you're a little frustrated at how you're not very good at R yet. That's absolutely okay. We have several more weeks at working within R, and we're only asking you to do a limited amount of things with R. This is not a course in R. It's a course in engineering analysis and data science. So being able to do a basic amount of data science in R is what our expectation is. This left quadrant here is what I refer to as your R script. This is what you're saving as your R files. This is where you're saving all of your code. In working with Swirl last week, you were mostly working over in this console. So in this console, it's harder to save work because this is what's actively being run as a code. That's why last week I had you save your history here or copy it into a Word file. But for the rest of the time, when we're not working in Swirl, all of your information is going to go in this R script here. If you close your R script, okay, say that we close this R script, I want to save it. You can go back to wherever you're saving your files, and mine's on my desktop, and you can reopen your R script, and it opens here just exactly as you closed it. If you are making changes to your R script, you can save it with this floppy disk right here. There are bigger save options up here, which will save your all of your open documents here, and sometimes all of your workspace, your current workspace. But mine right now are set up to save my current document, which is my script, which is also the same as saving my current document, which is my script. So these little floppy disks are how you're going to be saving your script. Last week, you saved your history here. This is not saving commands. This is saving what commands have been run. So to prove you did the assignment last week, you needed to save your history. To prove that you are doing your data analysis and your coding this week, you need to be saving your script. You can have multiple scripts open at once. So for instance, I have 2 scripts open right now. One is Holcomb from a research project that I did. One is my data science for this week. You can open more than 2. You can open several different scripts, and you can close them and open them however many times that you need to. You can also, along with the floppy disk, you can always use file and then save as. Name whatever you need to name it, save it wherever you want to save it. As a note, you don't need to save it as a .r. As it saves itself as a .r because it's an R file. You can't turn around and open this file in Word or Excel because it has a .r subscript. So it's a .r file. But you don't need to save this as a .r here. It's automatically put on there. All right, so that's a little bit about saving. In addition, several of you noted that R can be very particular. It is very similar to all other coding languages. Capitalization matters, asterisks matter, close and open parentheses matter, quotations matter. And a lot of times it's a lot easier to copy from commands that have already been written by somebody else, such as using my R script for this week, saving this script and just working off what I've already done, or using the question mark, read.csv. Once again, we're using CSV. So question mark and then a command, it'll show you information about this command. So read.csv is based on a read table command. There are a lot of different functions of read table, and it tells you all the arguments that are available to put into your read CSV command. It then explains to you what each of these arguments represent, such as, what is sep? Okay, sep is the field separator character. On a comma separated variable file, a CSV file, it's going to be separated by a comma. But if you're separated by something else, you can tell your read CSV command that you're separated by maybe a space or a semicolon instead of a comma. And it describes all the different arguments here. Then it gives you some information about memory usage, values, and at the very bottom, it gives you some examples. So a lot of times when I'm working with new commands that I'm not very familiar with, I will go in and just copy one of the examples into my script and change it to fit what I want to work with. So instead of retyping it myself and worrying about punctuation or where parentheses are ending, I'll just go in and copy an example, either from the question mark help file, or you can just use it from somebody else's CSV file, or I'm sorry, R script, like the one I'm providing for this week. Copy this and rename it to fit whatever file you're working with. All right. Another thing about R being picky is it tries to help you. So for instance, this example I just copied here. When I click on one of the parentheses, this last parenthesis, you can see it highlights the parentheses it's connected to. If I were to add another parentheses here, it would not like that. It tells me, okay, there's unexpected parentheses here. It's not closed. What are you doing? When I select it, it doesn't select another parentheses for me. So if I add another parentheses to close that parentheses, you can see now it's highlighting where my second one is. So now I have two parentheses that are, corresponding to each other. It still doesn't really like that because now I've added too many parentheses and it's kind of confusing what the command is. But in general, the rule is you can select a parentheses to see where its other open bracket is. This is true if you're typing your own code. So if you do write.csv and type in one parentheses, it automatically puts in a second one. If you type in a quotation, it automatically puts in a second one. It tries to help you make sure that you're closing and finishing your parentheses and quotations. In addition, if you are typing in something, it tries to guess what you are typing in. For instance, if I am typing in, let's see, okay, so read CSV, if I type read CSV, it comes up with this little yellow help box that tells you about this command. So it tells you what arguments go inside this command and what order they go in. So if you're going to use read CSV, the first thing you need to supply is the file, then information about the header, and then there's some additional arguments. Once again, you don't need to understand all of the arguments. You don't need to be an expert at R. You don't have to include every argument for every command. Just follow what I'm doing in the videos, follow what's being done in some of the tutorials if you need some additional help, but don't worry about every single argument for every command. All right, so read CSV, it tries to help you by telling you what's inside your command, what arguments are there. If you start typing a variable, it also tries to guess what variable you want to use. So it says, do you want to use this other command for table? Or do you want to use your variable that's already set here as a table? And it kind of fills in what you're typing. So it starts to fill it in early on. And so I want to use table 1, which I've already created, as you can see down here in my environment. So now, it kind of helped me get there. It even starts helping with commands. If you do something like read dot, it tells you all the different commands that are associated with a read command. Read CSV, read CSV2, read DCF. And you can scroll down and see that there's a lot that it's suggesting. So R does try to help you. There's also, if you type in read dot, let's do F table, you can get, your whole information about read.ftable. And if you do 2 question marks, it'll tell you information about all the different potential options for that help page. So if you have something, you type in something and you're like, okay, I want to know about like tables. Okay, well, that wasn't a good example. All right, I want to know about like pond. And it tells you there's no documentation for pond. You can try question pond, and that searches all of the search results, not just the specific help pages that are readily available at a question mark. So you can try question mark or double question mark if you really need a lot of help. All right, so it'll help you close the brackets, it'll help you close parentheses and quotations, it'll help you try to guess what you're writing, it'll help you try to fill in your variables, but it is very picky. You can't add any additional parentheses, commas, uppercase, lowercase. You need to tell the computer exactly what you are intending to tell the computer. All right, so those are most of the areas of concern that came up for last week. And so I hope that's helpful. If you have any additional questions, feel free to email me, use the discussion board, or use any of the different tutorials that we've tried to provide for this week. All right, so going back to our steps. First one, watching the video, you're already doing. Second one is to download your data set from your website. I mentioned in studio engagement with many of you, it would be easiest if you had a downloadable file that was a CSV file or an Excel file. I'm going to be going through several different options of downloading and uploading data, so hopefully one of these fits your current situation. If it doesn't, please email me and let me know, or email Dr. K, and we can try to help figure it out, either another data set or how to upload your current data set. So the first example I'm going to be doing is working with this groceries data set off Kaggle. It was just one of the first that I found. There's no specific meaning behind these data. So going to this groceries data set, I can see that there's a CSV here. There's a download option right here. So I'm going to download this data set. So it just downloaded. I saw it going through. I know that my downloads are going to my downloads file. So I check my downloads. Oh, here, I have my groceries dataset.csv that was downloaded as a zip file. My computer automatically unzips zip files and pulls out the files that are inside. If yours does not do this, you will need to open and unzip it yourself. You should be familiar with concepts like this from computer computational tools and some of the other programs that you've already had. But if you don't know how to unzip a file, either Google it or email me. So now I have my zip file that has been unzipped. I have my CSV file that's ready to be uploaded into R. But first, I want to download my data set and then check my data. So since we are not expecting you to be experts at R, it will be easier for you to manually clean up your data in Excel than trying to do it in R. Trying to learn a lot of new commands to manipulate your data for just uploading it is a little more advanced in this class. So it's easier for you to open your CSV file in a Excel document. That's typically where CSV files will open. Sometimes they'll open as a text file, and you can tell it that you would rather have it open as an Excel file. But then you can just look at what your data look like. So for this groceries data set, I have a member number of who scanned the groceries that were being bought, the date that the groceries were being bought, and then a description of the items that were being purchased. So looking at these data, I can see that there are thousands of rows of these data. I can see that I only have 3 columns. I can see that it appears right off the bat, every column has information. All the rows seem to be filled in, but the dates are slightly different formats. Some are month, day, year, some are day, month, year. And there are a wide variety of variables that are being purchased in the groceries file. So those are some things I noticed right off the bat. I'm not going to change them right now for this example, but if you have something similar, I would recommend you change all of the dates to the exact same format, which you should know how to do from CommTools. All right, so I can see that my groceries data set is looking good. There's not big gaps. There's not unused files. So that looks pretty good. All right, so I'm gonna save it, make sure to save it. And then first, watch the video. Second, download my data. Third, check my data. Fourth, upload my data set. So when I'm uploading a relatively simple CSV file, the command for uploading is going to be git CSV. So first we're going to check and set our working directory. My working directory is my downloads file. I can reset it to be my downloads file, and I should double check that is actually where my CSV files are downloading. It is. If your CSV files are downloading to your documents file, change your working directory to your documents file, or move your CSV file from your documents file to your downloads file. But make sure that you're telling the computer, my downloaded data are here. Second, check the data. We already did that, but make sure that you have a good looking CSV by the time you import your data. Third, we're going to go through importing data. I'm going to go through several different ways of importing data, and you can kind of see which one you like best or which one works the best. The first method is probably the simplest. You're going to go to File, Import Dataset from Text. Then it's going to open up your Finder window or your files, and you're going to select your data set. Then it's going to come up with this other pop-up, and it's going to name your data set for you. It's going to automatically encode. You can change this, but I would leave it. You're going to see if you have a heading or not. When you look at what your data will look like and what the data frame will look like, you can see that there are headings for my columns. So I'm going to say yes. Row names, leave as automatic. We don't have row names here. We are using a CSV file, so it's a comma separated variable file. If you are using something else beyond a CSV file, you can still use file, import dataset, and then tell it what sort of separation there are. Decimals are represented by periods. Quotations are represented by quotations. You can change both of these, but I do not recommend it. We are not going to change the way that we comment, and we are going to leave our NA strings, leave it as NA. If it is unable to read a value, it will pull in an NA. You can change what it makes this to be, but I don't fully recommend it. Then strings as factors. This is a little more advanced than we need to be right now. We can look at this a little bit later, but typically we're gonna leave strings as strings, and I'll come back to this a little bit later. All right, everything looks to be pretty good to me, and we are going to go ahead and import the data. And you can see that it pulls up another data set as another tab here, and we can kind of check it, see what it looks like. Looks like it uploaded pretty well to me. But the thing is, so I have groceries dataset.3. If I were to go in and type in capital grocery, gotta make sure I spell it right, groceries dot, oh, look, it gives me my data table here. It suggests it. I say, okay. And if I run it, it'll let me look at these data set. So you can kind of call your data here, but if you want to manipulate it, you have to then attach it to your script here. So now I'm going to once again do groceries. It comes up. I'm going to attach it. Then I'm going to run this command. So don't worry about this. The following object is mass from hurricanes, but hurricanes is my next data set here. So I'm attaching groceries 3, and then it's attached, and I'm able to work with it in my local environment here. Sometimes you will get an error here, and you need to read what your error is telling you and see if it's actually an issue for right now. So this is saying that my date, item description, and MIMA number are being masked from this data set, but I can see that they're still in this data set here. That doesn't seem to be an issue. It's still attached in here. So we're going to keep going. You can always copy this and Google it if you think that there's a bigger issue here, or you can do $attach and see what sort of information, maybe you didn't provide enough information. Maybe there was some missing command that was there. But we're just going to keep going and say that that works well enough for now. As another way of attaching your data sets, you can also, okay, I'm going to actually go back to a different type of data set for a second. So that's an easy downloadable CSV file. But if we have something that looks like this, which is a list of all the hurricanes that are from this year, it's actually from NOAA. You can see this table here. I went to the printer-friendly version of this table, so I kind of just get only the table information. This I can't download as a CSV file. I can only save it as an HTML page, a web page. I can't really can't figure out how to get this as a data table. So what I recommend doing in this case, because this is the easiest, would be edit, select all, copy it, and then paste it into a Excel document like this. You're then going to need to manually clean up the way that this document works. So these columns don't seem to have very much data in them at all. I would say that they only have data for certain time periods. I don't think I'm going to be using this in my analyses. I'm going to delete this row. Also, I don't really need this title here. I'm going to delete these. And it seems that my headings are taking up several different cells. So I'm going to make those into one cell. This doesn't seem to have enough data. I might delete that. And eventually my data table should look more like a concise, easy to work with data table like this. It can still be thousands of lines long, but you can see that I've made it with one set of headers. All the information is available. It's all in the same format. Sometimes you might find a random like asterisk or something throughout your data. Go through and try to remove that now, because otherwise R will tell you it can't read that line item. And it's easier for you to manually delete it in in Excel than it is to try to delete it in R. All right. So once your data once you've kind of changed your data from this into looking like this, save it, and we are going to upload this Excel file into R. So first I'm going to delete any additional sheets. It doesn't really matter. You can just save one sheet at a time. Then I'm going to go File, Save As, and then I have this saving as a CSV file. There are several options. You can do an Macintosh comma separated, MS-DOS separated. You could do just a plain comma separated. You can do a lot of different comma separated values, but saving it as a CSV file, I go to save. And then now I have this data table as a CSV file from this website. I did a little bit of manual cleanup. All right, so now I can once again go to File, Import Dataset from Base. And then my downloads, I have my hurricanes.csv that I worked on today at 11:50 here. I'm going to get the same pop-up window. Do you have a header? Do you want to import it under hurricanes? What do you want to do? So then I say import. And once again, I get another data table that comes up here. I will need to attach this table again. It's telling me that some of my headings are masked here, and that's okay for now. So this is working with file import data set from both a CSV file directly downloaded and a group of data that we had to copy into Excel and then save as a CSV. We can also then use another command that is read.csv. I mentioned this a lot earlier in the video, but this command will work instead of going to file import, you are going to tell the console directly to import this. So read CSV groceries dataset.csv header equals true. It'll read in these data as a CSV file right into your command window, as you can see here. Header equals true is telling it that I have headings for my columns. As you notice here, read.csv, it has a lot of different arguments, and I have only used the first two. You don't have to use every argument that's available. I said that before, but I want to reiterate it. You can get away with only using a couple arguments, and we can work on adding arguments later if we need to in following weeks. For this week, keep it simple. Use the first two arguments. Do you have a header or do you not? If you don't have labels for your columns, you do not have a header. Put false. Otherwise, you're going to put the name of your CSV file in quotations for the computer to go to your working directory, search for a CSV file named whatever you told it was named, and then read it into the program. So here I've read in my CSV file, but I haven't saved it as anything. So you can also supply a name such as, groceries, and you can make this into a variable. So now I have another variable, a whole nother data table that has come in here. It tells me its dimensions. And now I'm able to work with it using the name groceries. So you can also work with the read CSV file command. I was going to do an additional example here about if you are working with a website that you're trying to convert directly into a CSV file. There are some websites that might help you convert it into a CSV file. It was taking me quite a long time, so I wasn't going to explain it for you guys, but there are websites available to help convert to CSV file. You can also do web scraping. Originally, we were going to include web scraping as one of the lessons where you learn how to pull information, scrape it directly off the web, but it's relatively complex, and we decided that it was a little too advanced for this course. So there are websites that can help you convert a website into a CSV file, and you can also do web scraping, but it's a little more advanced than we're asking you to do right now. So I wouldn't worry about it. I'm actually going to delete this. All right, so using read CSV, we have the option to either file import data set or do a read CSV for a CSV file. If you remember read.csv, there are a lot of other ways to read in a table. So if you don't have a CSV file, I would recommend doing file import data set from text and then telling the computer what kind of separation you have, or trying to get your data into an Excel file and then saving your Excel file as a comma separated value. Those are going to be the two easiest solutions. If you are having trouble with that, please email me or Google it at any time. All right, I'm going to go through a little bit about basics of looking at your data once you've uploaded it, and basics of adding a little more arguments to your read CSV command. So as I said before, over here, you can use read CSV2 and read dlim. These are going to be pretty much the exact same thing. As we can see here, we can use read CSV2 to import the same exact data set that we did before. It doesn't really matter if you use read CSV or read CSV2 for what we're using right now. You can also read a delimited file using the read delim, but I don't know why you would do this if you're working with a CSV file, but there are other options. All right, when we are reading in a CSV file, our first argument is our file. Our second is if we have a header or not, and then there are multiple different options. We can see here we have header, how it's separated, what quotes look like, what our decimals look like, if we have a fill equals 2, what our comment characteristics look like, and an ellipses, because there are a lot more arguments that you can add. One of the arguments you can add are column names. So for the groceries data set, we already have the column headers that are there available in the data set, but we can tell it what we actually want these column names to be. So if we do call names, and then we use the C to bind this these variables, and then we say, okay, we have 3 columns. We want to name those columns store, date, and food. Make sure our parentheses are all closed, and then we can run that command. Now, if we look at the top of our data set, sorry, I scrolled too much, flying past it. We can see that we have store, date, and food instead of the original column names. We can also use another way of uploading data that is a little helpful. All right, so I'm going to be using the example that's provided on this web page here. So if your data looks something like this, you can copy your data. Actually, let's see. So when your data looks like this, and you can save it as something other than a web page, sometimes it'll give you the option to save it as a text file. So in our Mav, you can save as a text file right from this HTML website. So I'm going to save this as a text file. I already saved it before. I'm just going to replace it. And now it's in my downloads. I just downloaded it. And now I can try to do a read delimited information of this text file. So you can see that it kind of downloads a little bit weird. If we go in and look at the text file, you can see that that's pretty much what the text file looks like, exactly what it looks like in the website. And then we can choose another way of opening this file by using the command read delim file choose. So when you run this command, it opens your Finder for you right away. So you're saying read delim, but you're not telling it what file. You're saying I want to choose the file. So then you select what file you want to choose, and it'll upload it that way as well. So you can either read delim your command with using the file names, or you can read delim using choose file choose. It'll pop this up. You can also do read.csv file. It didn't come up. File choose, and then parentheses. Make sure all my parentheses are closed. It works. So now if I select groceries.csv, it'll also read in my CSV file from there. So there are 3 ways of uploading your data. You can either go to File, Upload Dataset. You can go to read.csv and then type in your file name, or you can type in read.csv and say file choose. So these are the 3 ways of uploading your data set. These are mostly focused on a CSV file because I believe those are, from what I've seen, the most common method that people in the class will be using. As I've said several times, if you don't have a CSV file, you can still use these commands. You can still use the commands that are available under the read table help page. And you can also use text files, different Excel files, and try to save them as a CSV file. All right. So let's look a little bit more on how we can look at just verify that we've uploaded our data set correctly. So I'm going to read in a CSV file of the hurricanes that I downloaded from this website. I copied and pasted it into Excel, cleaned it up, uploaded it as a CSV file. I'm going to upload it as a CSV file again. So table 1, read CSV, hurricanes, header equals true. All right. So now it has saved it as table 1, which I already had saved. And I can also, once again, instead of typing in the name, I can just choose it myself. It's the exact same thing. So table 1 didn't change, even though I just overrid it, but because I was doing the same thing. So you can use the command dim, D-I-M, to check the dimensions of your table. Mine are 357 rows by 7 columns. And you can also add a few additional arguments to how you want to upload your data. So if I look at table 1, I can see how my data are being uploaded here. And if I wanted to upload it a different way, I could tell it that I wanted to skip a certain amount of lines before reading. So right now I have skip set at 0. I'm saying don't skip any. But if I wanted to skip maybe the first 5, 1, 2, 3, 4, 5, then this would be my first row that appears. So let's see if that's true. This is on 1852 3/9/1852. So if I type in skip 5 and I reread my table and I look at my table again, I can see that my first row is 1852. Well, it became my header. 3/5/1852 became my header. And then, so I've told the computer that I don't want the first 5 lines of this table. I want to start at line 5. So I'm going to go back to skip 0. I don't want to skip any this time. And then you can also use a command argument, blank lines skip. So if you have any rows that are empty, you can tell the RStudio that you want to skip those. So you can skip those. You can also tell it the number of rows that you want. If your data are 600 rows, but only the first 400 are interesting, or if you want to only look at hurricanes in the 1900s and after row 401 it becomes the 21st century, then you can tell it exactly how many rows that you want. So those are some additional helpful arguments if you are trying to figure out exactly a portion or a subset of your data that you're trying to upload. So if I run this and I tell it that I want to skip 0 and I want 401 rows, then if I look at the dimensions of my table, well, they're pretty much the same because I didn't skip any and I didn't change the number of rows. If your number of rows is more than the number of rows you actually have, it won't do anything. But if I change the number of rows to 250, then I can see the dimension of my tables become 250 by 7. And if I look at table 1, the last columns were omitted. Typically when you run a command, if it's a really big table, it'll tell you it's reached its maximum. It omitted the final rows. But because these tables are long, you have to keep scrolling up and trying to look at what it is, blah, blah, blah. There are also ways for you to look at your data. So if we're looking at our data, we can use the dim command for dimensions, but we can also use head, where we just look at the first 5 or 6 rows of any data table. So head allows you to just see, what it kind of looks like looking at just the very top of it. You can also look similarly at tail, where it just shows you what the bottom looks like, the final rows. Or you can look at a summary of all of them. So summary tells you how many rows there are, what class they are they a character, are they a number, what kind of information you're getting. And then for ones that don't include letters, you have information about the max, min, and quartile ranges. We're getting near the end. You don't need to know how to do much more. Just upload your data, take a quick little look at it, and then you can also start to look at specific parts of your data. So when we look at our data tables, data 1, we have here, these are your rows and these are your columns. So when we want to look at a certain column or a certain row, we can actually pull out a specific part of our data. If we want to look at row 5, column 4, what value is in that XY coordinate, you just type in brackets, not parentheses, brackets, and you tell, I want row 5, column 4 of this position of this data frame. And it'll tell you exactly what's in row 5, column 4. If you want to look at all of row 5, you leave the columns blank and say, I want all of the columns, but I only want row 5 of this data frame using brackets. Then you'll get all of row 5. If you want to look at all of the table except row 5, you still use the same format, but you use a negative sign. So I want all of the table except row 5. And you can see that now we have all of this table except it goes 1, 2, 3, 4, 6. So if you had a row that you thought was kind of wonky data or a little bit out and you didn't want it, you can eliminate that row and then you can resave this as table 1. So now my table 1, my data frame, doesn't have a row 5 anymore. Anytime that you make any of these call outs or changes, you can rename it as your data set as long as that's still the data set you want to work in. So along with calling rows and columns by number, you can also call columns by whatever header they have. So table 1, I want to look at the column with the header date. And notice I don't have to use parentheses or anything here because I'm giving the table 1 specific information about what I want to view. So I want to look at date. All right, so for this week, all you need to do is get your data imported. You don't really need to do any sort of analysis. You don't need to do any of these, renaming. It might be helpful if you want to get your data all cleaned up and ready to go for next week, but all you need to do is get your data imported, make sure it's imported correctly, and start looking at it a little bit. What are your dimensions? What does your head of the table look like? Looking forward to next week, we're going to start looking a little bit more at the data and investigating any mean, median, max, reoccurring values. And so I've added a little bit of information to the bottom about some different commands and different helpful information for next week, just in case you had a little extra time, you want to get a head start. But for this week, just upload your data. Remember, there are 3 ways of doing it: file, import data set, read CSV with your file name, or read CSV with file choose. You can download your data sets directly from Kaggle here or whatever website you want. Hopefully you can directly download a data set, make sure it's going into your working directory. If not, you can try to copy and paste into Excel, or you can try to save as a text file. I know this video is a lot of information, but one of the comments we got from last week was that you wish there had been more information. So I hope that this is really helpful for you. Once again, there are a lot of helpful tutorials. Really take advantage of Google. Slow down and pause this video and try to work along with me, or reuse some of my code, right? So my read CSV, reuse some of this code, and it'll make it a little bit easier for you. I hope you have a great week. I really hope that you can upload your data easily and you start to agree with me that R can be really helpful and fun. So with that, I will see you all later.